overheated, faulty water pump. Okay. Direct cylinder. So according to this, they've got no hot water. So this is a secondary return. Okay. Flow fail. At this point in time, we've got no voltage to this pump. So we're just going to take the centre cap out, see if the impeller actually spins, if it's jammed. Okay, so we can just see the impeller in there. We just tried to turn this with a screwdriver. It moves, but it's very, very stiff. So I'll just say, impeller's possibly just jammed on this. We'll try and get some power back onto this now. So, coming into this diagram here, my pump goes to CT1. And it goes from there. Right, so what we've got no hot water. So we've got a flow failure on the control panel over here. There we go. Two immersions over on the cylinder. Neither immersion has got power to it, so we've actually got no hot water as well. So what we've kind of worked out is, it's not really my forte. However, what we've worked out is immersions and everything seems to be wired in like a series as opposed to a parallel, if I've explained that right. So the immersions, these will send power out down here into these relays down here, which energise and should go through. Yes, I'm just coming down now. All right, which should go through that pump relay there as well. And the pump's faulty, it's blown the fuse. We've checked the continuity on that fuse there, so we've tracked the power all the way through. So the pump's gone, and the pump's stopping was getting power to the immersion heaters as well. So we need a new pump, we need a new fuse, and we should be back up and running. Okay, so we're just replacing this pump today, which is wired in direct cylinder, heated by two immersions. There we go, which is a secondary return. Just pump back into the cold main, into the bottom of the cylinder. And it's wired into this control panel over here. So we just isolate the power, we'll check everything's dead at the pump, and we can start removing the pump and replace it. This also blew a fuse inside here the other day, so we'll replace that fuse as well. Okay, power's off. We're just going to check if it's dead. Okay, as you can see, that's the incoming side of the switch, that's the output side of the switch, so we're dead there. Okay, we can disconnect the electrics to the pump now. Just double check back over at the pump, it's exactly the same. Okay. Okay. Just double check this back at the pump. Nothing there, nothing there, nothing there. Okay. Right, so our electrics are disconnected. We can turn the cold supply off coming in. I'm just going to go and open a hot tap downstairs now. That should drain this circuit with a pump on. So, we'll be back in a minute. So, this is our old pump. Just put the camera so you can kind of see a little bit. We're just testing the resistance across this, so we've got it on ohms. As you can see, we've got some nice circuit through our leads. So we're going to test resistance across this pump. So with the wires disconnected, we're going to put the leads on live and neutral, and we're looking for about a minimum of 150 ohms. As you can see, we've got 36 there. So we know we've got an issue with the internals of this pump and the motor part, so this is why we're replacing this today. So it doesn't look like it's going to separate. We're not going to mess about too much, as we've got that, as you can see, so I don't want to start disturbing this stuff here. So hopefully our body's going to fit back on to this pump here. We are at 4 mil Allen key. Separated. There's some dirty water in there. Look at the state of that. Okay. Definitely need, because that's blocked, to get this body off. That's got to come off. I have to put a bit of heat on this, I think. Okay. The state of that. That's a domestic hot water circulation pump. That is riff. So we managed to get the pump out. We had to separate this valve while it was off. Unfortunately, we don't have another spare valve like this because they're crap. We've only got the lock shield sort of wheel head valve, which is a bit too big. I'm not going to mess about because that insulation's got asbestos in it. So I've cleaned the valves on the inside, put a file down and cleaned them out. Just going to put this pump back in now. Hopefully I'll have a nice seal on this. Okay, so we managed to get a new pump body in. There's a little bit of a variation in size. It's been slightly bigger. Fingers crossed. Managed to get it in okay. I'm just going to seal up. So, if you remember we just tested the old motor. That was giving us 36 volts, 36 ohms resistance. If we test the new one, cross the live and the neutral again. There we go, 231. Straight away you can see the difference.
Applied for them.
Yep.
They decided that they didn't want to work there. They wanted to be in Birmingham near the car industry.
Yeah.
So they bought this commercial property and then they've chucked like an industrial application on the back of it. We've had like the road up, extra power put in. They're running out of power left, right and centre.
Oh, wow.
You know what I mean? And they're just trying to blow things up down there as far as I can see. You know what I mean? But I just look after facilities for them and projects that are going on out here and back in Lincoln, like, so. It almost seems like they don't appear to be doing anything.
Yeah.
But they are, you know what I mean? We've got people like Rolls-Royce, Aston Martin, McLaren, all them people coming in for visits and everything like that. So it's
no way.
It's they've got 3 guys who've just sent over to China. They've got a year to get an order in from Europe in the rail track situation. You know what I mean? So they're just like busy on visiting everywhere, you know what I mean, trying to drum up business. But it's going.
That's the renewables for you, innit?
Yeah, it's gone crazy.
I'm surprised you're not working on sort of like inverters you can put on cars or something that's constantly moving that you can use. It will store electricity in it, and then
they've got a test bed downstairs in the back for all the inverters for the cars.
Yeah.
That they run up. This test bed will run the inverter like on a journey up to Scotland and back.
Yeah.
And bring it all the way back, and then they'll just take data off it and just find out where everything's going, what it's doing.
Crazy, isn't it, man?
Yeah. They're quite wild in what they do. They're a bit more cleverer than I am, mate. You know what I mean?
It's mad, isn't it, the way things are progressing.
Yeah. The combustion engine's gone out the window, hasn't it? You know what I mean? I'm a scooter boy myself, so I run a Lambretta all the time, and I tell these about it, and they're like, yeah, we don't deal with things like that.
It's crazy, isn't it, man?
Yeah.
It's like that. It's like in our industry, though. We're all changing over to, you know, they're trying to bring out hydrogen, they're trying to bring out electricity and stuff like that. And I just think it's so people are so far behind with technology in this country.
Oh, it's unbelievable.
You know what I mean?
It really is. You know what I mean? I come through, had a lot to do with heat pumps and renewable energy on houses before here.
Yeah.
And it's going crazy. You know what I mean? That is, you know what I mean? It's all new housing associations now. They're all on heat pumps, you know what I mean, with solar on the roof.
They are, but the problem, I mean, I lived in a housing association before they got a heat pump in there, and they'd spec'd the house wrong.
Yeah.
So it became inefficient, if that makes sense.
See, that's we was getting back in when it first kicked off. We was getting a lot of user error.
Yeah.
So the heat pumps, they'll only heat to sort of like 40 degrees C. You know what I mean? You're not going to get a great deal more out of them, and that's all dependent on the weather outside as well.
Yeah.
So when that 40 is not enough, they've got electric heaters in there that are backup on Mitsubishis and EcoDance and stuff like that. So they'd mess around with the controls, get the electric to come on, and then that's inefficient then, because like obviously they've saved money on the portion that they've heated it with a heat pump, but now they want extra, you know what I mean, they want it up at 60, you know what I mean, so that little gap's not far, but that's what's putting them and making them inefficient. So they're not really, you know what I mean, heat pumps, they're great on underfloor heating for a house, but they're not so good on hot water, you know what I mean, hot water, they'll heat it a little bit, you know what I mean, but no one wants a tepid bath or a tepid shower.
They're normally boosted with immersions.
Yeah, that's it, like, so, you know, it's saving in one respect, but not in a lot of others.
I know some of the newer pumps that are coming out can run higher and still be efficient. They are evolving. Like a lot of that's down to system design, the heating. You know, if they're designing, they should be designing now at a different mean water to air temperature, which a lot of the installers aren't doing. They're still designing at a DT50.
They're not looking at it. You know what I mean? And it's, the climate outside is respective to it all. You know what I mean? It's climbing a little bit, but not consistently enough.
Well, I mean, I get to so many though. They just set up the underfloor heating is set up either, whether it be a boiler or an air source heat pump, and they're just set on 240 volt switches. So it knocks it off rather than using the weather comp outside to bring it up gradually. So many bad designs out there, which is kind of giving it a bad name, if I'm honest with you.
No one wants to enter into it.
No.
You know, it's the same with solar. You know what I mean? So people who jumped on the solar right in the beginning, they're getting good grants and feedback from the government. Nice. But now it's that cheap and the grants and everything and that fine, it's just not worth it. You know what I mean? The amount of time it's going to take to get that money back, it's just, it's gone out the window.
But the thing is, that's the way, I think that's partly down to the way the government is selling renewable energy. Most people's impression of renewable energy is, it's going to pay me back. But it's not. That's not renewable energy. Renewable energy is about reducing the carbon footprint. If you get paid back, that's a bonus.
That's on top of what's happening.
But this is what people are looking at, thinking, well, where do I get my money back? It's not about that. They don't care about you getting your money back.
No, they're not bothered. You know what I mean? It's just like, say, carbon footprint on the world, or area or wherever it is, and that's all they're interested in. You know what I mean? It's like we've just had a shit ton of solar installed, or we're going through it. 200 grand's worth on a factory in Lincoln, and that's not even going to basically look at our electrical supply that we require at all. You know what I mean? It's just, but it's reducing in the eyes our footprint moving forward, because as a company you've got to reduce it yearly. You know what I mean? So that every year they're putting it in and it's going crazy. But then we've had CHP fitted there, which is great, it's saving the energy, but it's using gas like it's going out of fashion. You know what I mean? You save in one respect and not in another.
So that you can get hydrogen fuel cells. So I done a course, Heatgeek course, a guy called Adam Chapman, and he's into anything renewable. And he's got like a hydrogen fuel cell. So as the natural gas comes in, it strips the hydrogen off, and then that creates electricity, and then he can sell that back to the grid.
So that's clever, isn't it?
And the stuff like that. You know what I mean? They'd be looking at, that's what they're going to be looking at. If they're using so much electricity and using so much gas, it's like having people who know the technology that can do it. It's like a lot of the solar, you can use that for heating as well. So you can store it in buffers and then load shift it back in, rather than just using it as thermal PV.
As it comes,
There's so much out there, it's just knowing somebody who's got who's clued up on it.
It's getting it all into everybody, and it comes at cost. You know what I mean? Some people, I mean, the later generation certainly won't be entering into it.
No.
They'll just stick with what they've got. You know what I mean? 50 and above, maybe 60-year-old people, maybe they, if they've come into a bit of money later on in life, they might look at it. But it's the market's real.
What you've got to understand is as well, that weather comes all good if you're not ill. If you're ill and you feel the cold, it's not going to suit you. You're going to want to turn it off. If you're young and stuff like that, there's lots of circumstances where it doesn't work. You know what I mean?
It's too erratic, isn't it? You know, what's good for one person or one house isn't good for the next house. Or factory, or whatever application it is. It's what's good for one ain't necessarily good for
That's where the cost comes in though, doing the heat loss survey, and
yeah.
people don't want to pay for that heat loss survey.
Won't do.
And it takes time to do it properly.
Yeah.
You know what I mean? If you get that wrong, you know they're going to call you back, and there's no going back then. It doesn't matter how much fine tuning you do.
Yeah.
If you've done your calcs wrong, it's wrong.
Yeah, that's it, isn't it?
Yeah. Strange old world we're entering into.
It is, mate. Right, I'll leave you up with you. It looks like you know what you're doing, so...
Well, I make it look like I know what I'm doing, don't I?
That's the way forward. That's it. If I don't catch you before you leave, fella, just drop us a card at the desk, and then
no problem.
You know what I mean? We'll not mess you around, mate. The pay system and PO's all great here. You know what I mean? They'll just forward you.
Same with it.
Great stuff. Thank you very much.
Take care, mate.
See you later.
So it kind of goes down, if I remember rightly. I think it was R3. It's all powered through that relay there. So both my switches come down. They're wired through these relays in series. When it gets to R3, if I remember rightly, that starts energising these switches over here, and then we get power back out to our immersions. So it's kind of a fail safe. So the pump's constantly running by the looks of it. We'll obviously check that when we turn it back on in a moment. The pump's constantly running, which really, on such a small thing, you don't really want it running all the time because you're wasting energy. You can wire them PR switches. So I've been advised by the great Andrew Millwood, which is a good way of doing it. So when somebody walks into that room, pump starts pumping before they start drawing a demand for hot water, which will kind of save a bit of energy. I'm sure you'll be able to set those on delays as well, so they can run periodically if there's no demand in that area. Okay, so I'm just going to drag that fuse out of there. So I'm sure it was that one. Test the continuity across that. Okay, so we know that one's dead. So, new fuse to go in, 10 by 38. So, I can put that fuse back in there. One of the guys has just informed us that someone has been messing with this to see if they can re-energise the pump by dragging a fuse out one of the extractors. So we're just going to have a quick look which one it is that's got a fuse missing. This is a renewables test centre, this is. Changed. Okay, that's one of the dead fuse there. Replace that fuse. Two in here. Open that one. On the left. Last one there. Okay, that's okay. So we just replaced 2 fuses in there. We should. I'll start turning this back on now. Okay. You can hear the pump moving, which is good. We're just going to check now we've got voltages into our immersions and they're energising. So therefore, everything should start heating up, going back to normal. Check the energising there. Okay, so we've got power down there now. Let me just check that immersion meter is energising. Get it round into that terminal there. Okay, so that one's now live. The one above it, we'll check. That one's now energising, and that one's live. Okay. So that pump's in, that's running, that's circulating hot water back from the taps, back up and round in a loop. This is solar water. Hot water is supplied to the tap within a 30-second period. However, it's a cold cylinder now and this is circulating cold. So realistically, there's a bit of a design fault here. You don't want that circulating until the cylinders reach temperature. And also, if you've got bathrooms that aren't being used for a while, as someone pointed out to me, you're better off if you can wire PR sensors in there somewhere. And the pump will activate as someone walks into that room before a draw of hot water. State inside that secondary pump. So, we're up and running now. Pump's running away, circulating water around the system. Cylinder's cold, so we're circulating cold water. Both immersions are on. So we've got 3 kilowatt immersions there, so that's 6 kilowatt. So that's 6 kilowatt of energy we're wasting until that cylinder warms up. So you'd be better off if there was a way of wiring it in. That pump wouldn't run until the immersions are satisfied and the cylinder's up to temperature. And furthermore, if there's a way of wiring PR sensors in, so the bathrooms, so when someone walks in the room, pump starts pumping rather than just pumping away all day. Be able to save a bit more energy there.